This is a QuickField simulation example of ISO standard 10077, test case 7, fixed frame section and insulation panel. Here it is the example web page on quickfield.com. Here you can find all the information regarding this problem. For instance, this is the geometry model with labeled blocks and labeled edges on which we set boundary conditions. Here we have the cool side of the frame, and here we have the warm side. Here on the left edge we have a zero flux boundary condition. And also the main dimensions are also given here. General conductivities of the blocks are also given on this page. And our task is to calculate two-dimensional equivalent thermal conductance in accordance to the ISO standard, and we should get a result that will match reference thermal conductance given here. On this page we have some comments regarding the convection boundary conditions, and to solve this problem we should take into account that the equivalent air gaps, that the equivalent general conductivities of air gaps should take into account convection and radiation heat transfer. So to do this we implemented additional calculations in the Excel spreadsheet. Now let's go to QuickField. This is the window of problem properties. This is the problem of sticky state heat transfer model class is in parallel. This is the geometry model. Here we have air blocks with the general conductivity set here. All the air blocks have the same value of the general conductivity, which is the initial value for the subsequent calculations. Also we have some other blocks like EPDM, insulation panel, polyamide, and a PVC frame. Also we have edge labels with boundary conditions set on these labels, these edges. Here on the cool side we have the convection boundary conditions with the temperature equal to 0. On the hot side we have the boundary condition of convection as well, with the temperature of 20. And this is another edges of the warm side. And on the left edge we have a zero flux boundary condition. This is the Excel spreadsheet which is used to have automated calculation of equivalent general conductivities of air blocks. Here we have some instructions how to deal with this spreadsheet. And to get started, we should list air blocks in the first column. Else, then we should mark for the type of this block. We should type 1 or 2 for isolated cavity or for slight ventilation. And also we should set initial internal conductivity for each of the block. Now we can start the process. The first iteration is done. Let's do the second. And we should repeat until the error will not get significantly small. Well, 7 steps is enough. And we're back to QuickField and calculate the equivalent thermal conductance. And to do this, we should first add the warm side edges to the contour of integration. Now the contour is drawn, and we can start calculation of the heat flux. And this is the value of the heat flux passing through this surface. In order to get the value of equivalent thermal conductance, we should divide the value of heat flux by the value of temperature difference, which equals to 20 degrees. And one can see that the same value is pretty close to the reference one